ago we lived in peace with native cedar trees that grew on cliffs and draws where fires could not reach. Then European settlers stopped the fires prairies need, which started an invasion of a million cedar trees.
Yeah, you can hear me. All right, hello. Thanks for coming back from the break. You could have left, No one would have known. Yeah, believe it or not, I'm going to talk about woody encroachment. Like you said, I am the grounds manager and horticulturist at Dyck Arboretum. That's in Hesston. Show of hands, how many of you have been there? Oh, yeah. Lots of you, yeah. So we are a 30-acre public garden. We have a prairie restoration as well as more formal gardens and a pond, a visitor center, event venue. And our big focus is helping people to appreciate Kansas native plants. We have non-native plants. We are, a public garden meant to get people outside and help them explore the plant kingdom. But we're focused particularly on Kansas beauty, the appreciation of Kansas native plants. So I've been there 10 years. I manage their grounds, do their arboriculture, tree trimming, a lot of tree felling. I feel really good every time I cut down a tree, which is so weird for working in an arboretum, but that is how I feel. And I recently went back to graduate school. Why did I do that? But I am now getting my master's degree at WSU in ecology, specifically in grassland ecology. So today we're going to talk a little bit about my project, which is ongoing. I know it was advertised that I would tell you the effect on pollinators. TBD. The effect is TBD, but I'll show you how I'm studying the effect and what my thoughts are. So first, we're just going to go over woody plant encroachment. You already know. We'll basically skip it. But I think cedars are a unique encroacher. And I think they're different and should be measured a little bit differently and managed differently than others. So we'll get into that, then cover my research questions, how I'm going about answering those questions, and we will not do statistical analysis because it's terrible. Truly awful. So I really like this. Again, this is just showing how woody plant encroachment happens. And for folks who are not from the grasslands, like I'm in a department with students who are from Ohio and who are from the East Coast and the West Coast. Trees good. And I have to tell them, no, trees bad. Trees very bad. But it happens all over the world, and it happens like this. Obviously, there's grass-dominated landscapes, and they slowly but surely can turn into woody-dominated landscapes. Something that the other programs didn't go into much is the drivers of this. We know that fire suppression, right? The lack of fire is a big problem. And that's one, because we don't have these big open spaces like we used to where fires can roam for thousands of miles. Part of that is because we removed all the native people who knew how to do that and manage it. But there are other drivers too. So, of course, changes in land use, right? If we start farming areas and it parcels up these grasslands, even if you get a nice hot fire going, if it runs into a fallow field, that's it. So you start to get a patchwork type of mosaic where even if you get a good fire going, it's too small to make a big impact. It stops at those farm fields. Also, we know that grazing is essential for woody plant control, but it can also be a driver because if you overgraze, you're creating those bare spots, you're disturbing the soil, and now the tree seedlings can really come in and colonize. So there's a balance and what kind of livestock you're grazing. And also climate change. So we know that as carbon goes up in the atmosphere, we're finding that woody plants are better at using carbon dioxide than grasses are. They're a little bit more efficient. And so that's pretty bad news because it doesn't look like we're going to have any less carbon dioxide in the atmosphere. And so in some cases, it's giving the woody plants an edge, faster, more rapid growth. I read a paper on poison ivy that said poison ivy uses it really efficiently. And I thought, really? That's the future is a carbon-heavy atmosphere full of poison ivy? Count me out. I'm done. So there's a lot of different drivers that can cause sort of the perfect storm of woody encroachment. It's no one thing and it's no one place. Of course, we are here in the Flint Hills. I am attached to the North American Great Plains grasslands, but there are grasslands all over the world that are in danger of the very same thing. Woody encroachment is a global problem because grasslands everywhere are also quite fertile. So anywhere there are people and open grasslands, there is land change. We want to farm it, graze it, control it in some way because it's a very profitable place to live. So grasslands all over the world are a really, really threatened ecosystem from humans and also from woody plants. But I think eastern red cedar should be like public enemy number one. It is for me. When you climb through them all summer, you start to develop a unique hate. But particularly, up in University of Nebraska-Lincoln, they have an awesome resource called the Cedar Literacy Project. Great website. OSU also has great stuff on this. This graphic is from there. It's showing the collapse of the Great Plains biome, which is dramatic but true. We are seeing so many acres by the day, by the minute, being overtaken with trees. And they say about 7 million acres across all of the Great Plains. 7 million acres. Now, that's not just cedar, but at least in the past 30 years, it does seem that cedar trees in particular have proliferated really quickly. The thing about cedar trees is that they're more of a people problem, I guess is what I would say. So there's lots of native trees that can be good in small amounts. We love our bur oak trees, even some of our less lovely trees like a hackberry they have their place. Cedar trees were planted pretty prolifically as part of that erosion control method through the 30s. And even before that, right? The Homestead Act, trying to get people out here, people were planting trees because most of our ancestors came from Europe. And what does Europe have? Trees in little square plots around your farm. That was the norm. And so cedar trees, even now, we continue to have that European mindset that to be valuable, we need timber because the whole economy of Europe was run on wood. So what do people do in 2026 when they buy a little place in the country? They surround it with 100 or 200 cedar trees, and it just makes my blood boil. Because I try to tell people that cedar encroachment is just different. It is not the creation of a forest. When people think forest, they have a warm, fuzzy feeling. It means beautiful squirrels in the trees and birds in this open forest floor. It ain't like that, okay? A fast encroached cedar area has almost no walkable land. You can't get through. Almost nothing can grow in the understory because of the shape of the tree. It's not like an oak tree that's eventually going to canopy out and create habitat underneath. Doesn't do that unless you trim it, right? So a cedar forest is uniquely bad, I think. And it has wide-ranging effects. So we talked a little bit about birds. The mouse is happy because he's the only one who likes this, and we'll get to that. But we'll just talk briefly here about birds, plants, and mammals. But of course, birds, we already know that increasing cedars can be positive for generalist birds, right? Robins, cardinals, woodpeckers, birds that really are more eastern species, they can continue to move west as these trees move west. So I guess that can be a good thing for some birds, but in generally, our grassland birds, which are much more endangered, they obviously can't handle that. And you'll see here this lovely graph that you basically already showed is that prairie chickens, of course, they will just flee if there's even one tree within a half mile, They can't handle even one tree. And that goes to show that if you move out to the country and you just want one tree, still makes a big impact. One person and one tree can ruin the habitat for a very important bird. And we see similar patterns with things like grasshopper sparrows, even killdeers. Not as dramatic, but there are lots of bird species that don't want trees around. Plants. Now, of course, I'm a horticulturist. I'm a plant person, so this is my deep interest. But we do see overall that as cedars move in, plant diversity takes a dive. Again, same graph. It's fine. It's fine. But yeah, what we see here is like in a 10-meter circular plot, they went out and they measured the species richness. How many different species can we count? And we know that in a healthy prairie, you can throw out a hula hoop and get 10, 20, sometimes even 30 species if you're really parsing through it. If you throw a hula hoop out under an eastern red cedar, bare dirt, maybe some sedge, maybe a dandelion. Not much, okay? So we see a huge drop-off, especially beneath the cedars, but even around them. And then lastly, mammals. So, of course, deer. I think deer are the problem, man. People want the deer, and so then they get this idea they need cedars. It's garbage. But anyways, we do see here that about from 0 to 30%, if you're looking at small mammals, it turns this really species-rich community of small mammals that would have lived in an open grassland. And what did this is a great quote, into a depauperate community, dominated by one species, the gray mouse, or white-footed mouse. So this is a really interesting graph. This is just the probability of finding these species as cedar percentage increases. And you see, as cedar percentage increases, your probability of finding anything except a dang old mouse goes way down. So we're really losing diversity on all these different levels. And if you notice, I stuck with the lower trophic levels, right? Small animals, birds, plants. Because your diversity at that level determines everything on top. So if we're having problems down here, we're going to have problems up top in the food chain as well. But what we don't have a lot of data on is insects and floral resources. A lot of good study has been done, like with the RAP project, on especially grassland forage. That is a popular topic because it has to do with economics and money, and there is some money behind that. Flowers are not necessarily economically valuable, right? Nobody's out there farming purple poppy mallow. So there's just not a lot of research on it. And as I tried to get grants, I found out nobody wants to give any money for this. Shucks. That's fine. That's fine. So there are just a few studies. One of them that I found had to do with the American burying beetle, right? It's an endangered beetle, so there's a little bit of interest there. And basically what they found is that cedars reduced American burying beetle numbers because it reduces their ability to find carrion, to find dead stuff. Whether it reduced their ability because of just physical obstruction, they can't drag their prey around all these branches, or whether it was a census thing. Cedars do have a strong smell. You know, I'm not sure what it was, but they saw a decline. So that's interesting. And also there was a mosquito study. People were trying to ascertain whether there are medically important mosquito species that might be moving their ranges because of trees. If you imagine being a mosquito out on the open prairie, it's kind of tough. It's windy out there. It's hard to find what you're looking for. But if you close it in with a bunch of cedar trees, suddenly the air is still and you can fly a little easier. And what they found was, for some species, no change. For a few, there were some increases in abundance of specifically disease-carrying mosquitoes. So there's a little bit of research there. But when I mean I've looked everywhere for insect research on cedar trees, it's just not much. So I'm going to do that, I guess. I'm going to fill the gap. And so I have a couple personal theories that I have been developing of ways that I think cedar encroachment might be affecting insects, especially insects that are of economic value, like bumblebees, right? And also insects of conservation value, like butterflies. It's easy to get people jazzed up about butterflies. But basically, there are some direct and indirect mechanisms. The first one is that I think cedar trees may discourage foraging. Again, if you imagine you're a bumblebee, you have evolved for many, many thousands of years on an open landscape. And suddenly, you have all of these obstacles that are now visual obstacles, flight obstacles, and perhaps scent obstacles, because they're also sensing flowers through smell and pheromones. So that changes things. I also think that the cedar trees are creating shade, and shade decreases the air temperature directly around them. And that may limit the amount of foraging time these insects have. Most flying insects have to come up to temperature, usually about 70 to 75 degree body temperature, to fly, right? They don't make any of their own heat. So that's why you see them out in the sun, sunning, especially in the early morning to get up to temperature. If there's more shade in an area, especially over a large landscape, that may decrease the hours of day that they can forage, which is going to have an effect on how much food, how many calories, how many babies they can have. And the indirect mechanisms would be similar with the shade. Shade may be also affecting their food source. There are plants, say like Baptisia, full hot sun all day. That's what it has always grown to and evolved to tolerate. I'm interested to know that if you have these big stands of cedar that are casting a lot of shade, are there species that simply cannot subsist even in the gaps, right? Even outside the drip line of the cedar, we might start to see some of these species disappear because it's just too much shade. Grasses may grow, but perhaps there are certain flowers that can't hoof it. And then also, I think it might be reducing flower size, right? The display size. So what I'm seeing at some of my research sites is that there are flowers there. They're present, but they're not as tall. They're not as vibrant. They're not blooming with as large displays. And that's an energy cost, right? It costs energy to put out a flower. It's possible they don't have the energy, either because of the shade or because they're competing for moisture. So there can be all these really, really granular changes in the flower community of what would be found in an open, sunny prairie. These cedar trees may be biasing it towards more shade-tolerant species or maybe spring ephemeral species. I'm interested in those changes that we might be occurring on a grand scale, but we're missing. So I won't make you read these, but the gist of it is that I'm going to be comparing between sites and also within sites. So I have 9 different sites. And my basic thought is that when I'm comparing between my sites, those with less cedars, those that are more open, will have more flowers, bigger individual flowers, and more insects. And with that comes a little bit more diversity, abundance, etc. I'm also measuring the proximity. So within sites, within my little plots, I am measuring from each individual cedar. So I'm kind of getting on an even more granular level. I'm thinking that flowers that are farther away, or locations farther away from these cedars, will have more flowers, larger flowers, and more insects. And I'm really interested to see where the threshold is. At what distance away do we see a drop-off or an increase? Because that can have real conservation value. It's unrealistic to think that people are just going to go out and cut down every cedar, right? It's probably not going to happen. But if we could set some real values, say for pollinator conservation, maybe the number is 20% or maybe it's 15%. It gives people something to aim for on their land. So my study takes place in Harvey County. I have 9 sites. This only shows the 6 from last year. I'm in my second year of data collection. And so I have 9 sites. These are all privately owned sites. I work with private landowners, and they're very generous to let me tromp around. They are all intact remnant prairies. So I'm trying to avoid any area that has been reseeded or farmed because, of course, that's going to be a very different plant community. So I'm focusing on intact grasslands that have been colonized by trees, and we're all within about 20 kilometers of each other, so we're not getting, I'm trying not to get into too far into like the true Flint Hills community, and I'm also trying to stay away from the Sand Hills community. I'm in the foothills to the Flint Hills. I'm trying to stay in there. That's what we call it in Harvey County. It's just a little hilly. So you can see I have a variety of sites. These are just aerial images from Google Earth. I have some sites that are completely open. That looks like a wheat field. It's not. It was just hayed. Some of my sites are hayed. But really, really nice, open, intact prairie, and then completely encroached. Sometimes I'm crawling on my stomach with my bucket. And my sweet husband, who is here, he's like throwing me the tape measure. It's awful. If any of you would like to come help, I'm taking applications. So I'm trying to find, amongst my 9 sites, I would like a site that demonstrates, each one of these type of gradients of encroachment, from fully open to some pretty big gaps, maybe a tree here and there, to smaller gaps to no gaps. And I've been really lucky to find pretty much a site in every type of location. So this is kind of what it looks like. At each site, they're about 30 meters by 30 meters, and then I have 16 subplots in each one. So I'm going and taking my data at each one of those plots every month. And I'm only placing them in the gaps because we have really good studies on what's under a tree, and it's not interesting at all. So I'm not going to reinvent the wheel. I'm only interested in the gap, right? What's happening around the trees. And so the first thing I do is I quantify the level of encroachment. We do this by using a canopy cover, a forestry tool. You hold this little convex or concave mirror in there, and you're counting how many squares are reflecting tree cover. So that's easy. Each subplot gets a score, and then you can kind of get an average for the site and an average for the plot. And then I'm also measuring from each plot to the drip line of the nearest cedar. This is where you get poison ivy. This is the spot. And ticks. I think I'm up to 30 ticks this season. Oof. Yeah, the tick number is real. But you're measuring to the drip line and inside to the trunk. And some cedars are, pretty small, but I think I measured one that was 10 meters around. I was 5 meters to the trunk. Huge cedars. So that allows me to not only get a proximity to the nearest cedar, but also to get a feel for how big the average cedar tree is, because I have kind of a radius of the tree. Once the not fun part is done, then I can do the fun part, which is counting flowers. So then I go out every month and I am counting what's blooming, who's here, and also how many. I kind of want to know the density. So maybe there's some baptisia, but is there markedly more or less in certain places than others, right? Are they only in the gaps? Are they existing close to the tree? And then I'm also measuring to the nearest forb outside my plot, because sometimes there's nothing in the plot, and then you get a lot of zeros. So I'm trying to get as much community data as possible. So over the course of 2 years, I can get a real full picture of what is blooming there. And then this summer, I didn't do this last summer, but I'm adding this floral display size, trying to quantify, are the flowers thriving or just surviving? And so basically, I'm targeting a couple species here. Daisy fleabane. This is a common one. It's kind of an annual, it's not my favorite flower, but it is abundant. So I got to go with what I've got. And scurf pea, petalomelium. I'm going to be counting these and their abundance, but also measuring the individual flowers to see what is the average radius of the display or the height of the spike and how many, to see if there is any significant differences in these cedar encroach versus open sites. And then I'm also doing insect observations. So I am fundamentally kind of lazy, and I do not want to sit out for hours a day watching bugs, because I love them, but they don't always show up when you want them to. Last year, I just sat and watched, and I got terribly sunburned. So this year, I'm going to use trail cameras, and I have found out that they're really bad at capturing insects because they're really made for deer and raccoons and big things. But if you go to Dollar General and you get reading glasses and you break out the lenses and put them on the trail camera, it brings everything really close. So I'm a big believer in Dollar General glasses now. And it works wonderfully so far. So then you can focus really, really close. And I have great hope this year to get nice images. And I'll be taking like a scheduled capture. So I can put it out and I can have it capture over many hours, like 1 minute of video every 10 minutes. So then I'll let it do that this summer many, many times. And I will, when I have time in the winter, watch many hours of bugs. Some people watch Netflix. I watch bugs. So I'll be doing that this winter. And basically what I'll be doing is trying to count the abundance of insects, comparing across sites, and also identify who's there. Is it mostly bees? Is it mostly butterflies? Is there a significant difference? So I'm going to try to identify to the family level, if I can, to see who's there. And so you see my little trail camera. I'm going to put a flower I'm going to bring a flower so that it's standardized among the sites. I think this month it's going to be bee balm. So I'm going to bring a Monarda. I'm going to put it out there in the site and have my camera pointed at it. And basically I'm just counting it. If it touches the flower, the bug counts. So wish me luck with my technological endeavors. I'm not good with cameras. Okay, and so my expected result, right? If everything goes according to plan and I get wonderful data that proves my personal hypotheses, we should see something like this, that as cedar encroachment increases, all of our insect and flower diversity, abundance, all of that should start to go down. If I'm correctly synthesizing these other papers that I've read, right? That's what I expect. I will say that I am shocked by how much diversity some of these heavily encroached sites still have. I'm able to find gay feather and scurf pea and baptisia, all of these lovely species, in a gap that may only be a meter wide between trees. So I'm kind of heartened by how resilient these iconic prairie flowers are, but I don't know if that's going to be statistically supported or not, but anecdotally. And I think that's the end here. I would just say a thank you for this ongoing project. I have a wonderful advisor at WSU, Dr. Leland Russell, and this is not his thing at all, not his expertise, and he's really encouraged me to just go for it. So, either that's him being confident, or if I fall on my face, then it's my problem, I guess. And also a big thank you to my private landowners and Dyck Arboretum's Prairie Landowner Network. They started a Prairie Landowner Network many years ago to help collect seed for their prairie restoration, which was to be local genetic and local ecotype. And that Prairie Landowner Network of cooperating landowners who let us survey their land and walk their land and do all those things have really been crucial to this project and many other research projects. And there's some references if you really want to get into it. I'll take questions maybe with the group. Yeah.
Will increase before it's too late. Stop those cedar trees while you still can. Before it's too late, stop those cedar trees.